Still not showing at all, at all, at all. Not sure why it is not coming up. Not coming up at all. Something not coming up. 1 minute. Photo. Photo. All right. All right. Are you seeing my screen?
Yes, sir.
All right. So what you're seeing here is the wind map at 300-year return period for Jamaica, right? If you, just for argument's sake, you're asked to find the wind speed here for I'm just throwing out something randomly. The wind speed for Saint Elizabeth. What figure you would use?
The 135, sir.
130, but look, all right, 135 roughly. All right, suppose I'm more defined and say Black River.
140.
140. All right, so you kind of get an idea. You see the difference in terms of the demarcation and the contours, okay? And 130 what? 130 what? What is the
So
unit?
would this be miles per hour?
Yeah, see it right here. You seen it?
Yes, sir.
All right. All right. So let's move on to the board. All right. If you are given a win question, right, and the general information for the win, right, is I'm just gonna do a plan. I'm gonna just do a plan view and possibly a plan view of a gable roof, and I am saying that this is south, north, This is what? East, west, west. Okay. And I may say to you, you know, I want you to calculate the wind load in a particular direction. In this case, it could be, east, west, north, south. Okay. All right. So the information that is given here, in this case, it's given. It's not always given. V, V, which is the oh, sorry, that's the wrong thing. All right. That's the wrong thing. One. All right. So the information that is given here, information. So 160 miles per hour. All right. The the building exposure. So I mean to say exposure, EX is C, right? The this may given as well as it may not be given. You may have to use, but based on the type of structure, the rigidity of the building, right? So, but in this case, the rigidity, the um, rigidity or rigid structure or rigid G is equal to 0.85, and that is typical um, for based on the wind load, based on the wind rigidity of or the flexibility, based on the hertz below 1 hertz or above in terms of flexibility. The category of the building, is based on the type of building. This could be a hospital, a school, or so on. So the category, all right. So C category, uh, in this case, category 2. And I could say the building is located on a homogeneous topography or some flat topography. So the topo, um, flat. All right. All right. Having that information, right? Having that information, what you want to find is firstly, you want to find the velocity pressure. So what I'm finding, the um, velocity pressure here. Are you see my screen, right? Clearly and all right? All right. We know that the velocity pressure for miles per hour depends on the SI unit or what they refer to as the um, imperial unit. But in this case, we have the information in miles per hour, which is Q denoted by QZ is equal to 0.256 KZ. All right. Um, yeah, that's the exposure. Sorry, the directional factor, which is KD, the, the elevation factor, E, right, and V square, right? Okay. So we require to find all of these variables, or yeah. So in finding that, um, let me just refer to the table here. So we're going to be using up a table a little bit here. So in finding the KZ or KZT, yeah, as a KZ or KZT, which is a topographic information. if you should look in table 26, 20, is it table 26? No, it's table 26.9. Can you find, can you open your thing there? The manual 26.9. All right, I'm going to run through this fast because you know, I think I just wanted you to kind of see what I was doing. But you understand what I'm saying. All right, so I'm just going to go through this quickly. All right, so K, so we're going to find the different K. The different KZT is equal to, in this case, is 1 because its topography is flat. Then the directional, which is KD, right? KD is equal to the, and this has to do with the main frame. So when you're dealing with the main wind force resisting system, we already, right, we have, this is equal to 0.5, 0.85. um, the elevation factor, which is Ke, is equal to 1, all right, because there's not much information given with regards to the mean sea level, okay, all right. So what you're going to find is that, I want to refer to some table here. Uh, so look, so I want you to look at section 26.9. I want to find it, 26.9. It's all over. It's from 26 point, come on, point 6.
Sir
What
Ron,
number you have there? What number?
268.
Say what number?
268.
260, 260. Oh, what's the page? 321. Okay, good. So so these are the different things. So we're dealing with a mainframe. We have looked at only mainframe so far. We don't look at any cladding. Okay, is that clear? We haven't looked at the cladding. We all look at the mainframe. All right. So all right. So we discover those, the the directional, the exposure, and so on. All right. So based on the table, all right. So we're gonna go to this table next, which is dealing with the velocity exposure, which is KH or KZ. There's a formula that I've left out. Have I left out something? Yeah. Yeah, I left out something out of this. I left out so a value here. You see that?
So it's a KZT, I
Yeah.
think it is.
Yeah. All right, let us quickly. All right, so the T. All right. All right. K. Uh, this is okay. D. K. E. V. All right. All right. Hope you understand. Is that writing? From, I get that KZT from the table, from the, based on the, based on the topographic. So this is a topographic factor. So it is saying here, if you look at it here, if the site condition or location of a building or other structure do not meet all the requirements here. So normally on a flat site, you tend to use a factor of 1. On a hilly terrain, then you have to get into this equation, which is 1 and K, 1 to 3, and then you all, raise that to the power 2, and that is information is given, all right? in terms of a table format. Where is it? Which is what these are the information. All right, basically the KE, which is elevation, which is the elevation factor. Okay, so it's if the permitted, so in essence, the ground elevation to adjust based on the air density shall be determined in accordance with this table. If it is permitted, take E to be KE to be 1 for all elevation. Okay, so if it doesn't give you any information with regards to the mean sea level on which this structure is placed, if I said this structure is placed two 2 feet above mean sea level, then you would come and look and take a figure here. You get me? But if it doesn't give you information on the how high the structure above mean sea level, then you use 1. You get that? You want you gone again? Yeah, KZ. All right. So now we have all the factors so far beside KZ. All right. So if you should plug in the information given, all right, into the table, so you could put this into a table form. You could put this into a table form, such as where we have, something looking like, hope this to give me justice. All right, so in this case, this is KZ, this is Z, sorry, this is Z, and Z is the height. What I didn't give you is did I give you the height? All right, let me just give you the height here of the structure. This is, I'm doing a cross section of the structure. All right, so this is a cross section of the structure. All right, the height of this structure to here is 20. All right, and to the peak is 10. If it's a case where you have gotten some form of slope ratio, just for argument's sake, um, a slope of say 1 to 2, or we call it now 3 to 9, a slope like that. What it is telling you is that it's basically rise over run. Okay, where this is saying this is 9, this is 3. That is the slope. Okay, so I'm saying that the slope is that over that. You could go ahead based on your figure that you get and work out if, let me tell this width is 40. Okay, so if I give you a slope ratio or a percentage, you should easily well work that out if you don't get the height of the structure, the height of the roof. You get that? Is that clear now? All right. All right. So let me just erase that. Somebody saying something there. All right. Somebody mic open, saying something. All right. This kind of a little bit untidy, but let's see how best we can capture some. All right, all right, all right. All right, this is um this is QZ. All right, and this is pound per feet. Okay. All right. Let us go. So, what is the height of the structure? The total height of the structure. Let us go to, in terms of the, we call it now, the table. So the table dealing with the velocity pressure exposure coefficient, which is denoted by Kz or Kh. Kz is the is a windward, okay, and H is side and leeward height, okay. The Z denotes there is difference. So we're starting from 15 and we go up to 30. And so we're going to be, remember the exposure that we have is exposure C. There's an exposure C building. Okay. So if you should have an exposure of say C, then this becomes the 15. So we're going to put in 15. Then this KZ based on the table is 0.85. All right, this becomes 20. This is zero point 0.9. This is 25. This is zero point 0.9. Are you following in the table? Are you following in the based on the table? Okay. All right. Um, this figure, which is QZ, we would have calculated QZ from the velocity pressure here. So if you should plug in all these values, including your KZ, then this figure that you come up with would be 31.26, 33.10. Then the what we need to find, I didn't say it to you, is to find H, which is the mean height. Okay, so the mean height is a distance, yeah, from about here down to ground, and this is 25 because this is 10 half of that, then that is 25, that is H. All right, so that is H. So H here is 25 um, feet. Okay, all right, back up. What you say that again, Javarsi? All right, 15 to 30 is because on the windward side, right, the wind varies according to height. The wind pressure varies according to height. So the wind pressure would behave like that. You get me? But on the other, all the other sides, and that's why we denote the other sides to be KH and not KZ. KZ only applies to the windward side. So H is a mean height that will be used throughout the using the equation. So we need a mean height. We're gonna see how we get to that. We come by H by adding 20 plus half of 10, which is falls here. You get me? Which is the mean. What is the mean height of the roof? Which is 10. Half of mean height of 10 is what? 5. Yeah. But suppose I didn't give you that as straight cut and I give you some other factors, then you would have to calculate based on Pythagoras theorem. That's it. All right, trigonometry, yeah. You would have to find out. I could have given you a percentage, 10%. But eventually you're going to have to work it out. What is the percentage? So we're gonna let me just go ahead and work out this since we are on it. All right. So this height, okay. Oh, that area is a while ago. I'm not sure. Okay. All right. Let me just back up. Let me just work out that while you're at it. All right. All right. So half of the length of the roof is like that. This is what 20. This is 10. Therefore, you can easily find this by tan of what equal to 10 over 20. That is equal to the theta is equal to the tan inverse of that, and that is equal to 26.6 degrees. Okay, so that is the slope of the slope of the roof is 26.56 degrees. Okay, that becomes important when you're finding the the pressure on the roof, the pressure on the roof. All right, let me just go through this now. All right, so this is calculated by. All right, so we're gonna do so what we're gonna put in, which is this formula here. So this formula would be let's go. So Q here is Z is equal to 0.552, I mean 0.0025, right? 6 multiplied by K, which is what is KZ? 8 KZ. Okay, yeah. Multiplied by KZT 1 multiplied by 1 multiplied by, am I right? 1. V is what multiplied by 160 square.
Sir, KD, 0.85, sir.
K, which one that?
KD.
Yeah. Did I put that in?
No, sir, you put it as 1.
I put it as 1. Okay. Yeah, my bad. Which was it? I think it's here. 8 was a 8.5, right? Is that right?
Yes, sir. See it right there.
Yeah. Yeah. So every time you put in the equation into the formula, every time you use a different KZ value, this will change and it changed and it is being reflected here in terms of the numbers.
So I'm not
You get
getting
that?
31.26, sir.
You're not getting what?
31.26.
You're not getting 31.126?
No, sir. 31. No, I'm getting 47.35.
Yeah. Let's go again.
I got the same thing as Lajani, sir.
Yeah. You square this,
Yes, sir.
Yes, sir.
you square that. Mm, all right, so let's go again. So you apply. So we're saying that it is. So let's go. 0.88256, right? Multiply by what is k, right, multiply by what is it, t1 multiplied by d multiplied by 1 times 47. You get in? That's what you got.
Yes, sir.
I wonder where the mistake went by. One minute there. Just give me, let me just check some, double check something. Yeah, that is where you got. Um, 1 minute there. So we have 20 kz. Hmm. Just a minute, just a minute. Let me just double check something. Hmm. What about if you put in the other figures? You're still getting? You try the other figures?
What other figures, sir?
20, 20 point nine, using point 0.9.
No, sir. I'm not getting 33 for
You're not getting
20.
33?
I got 50.14.
Yeah. I think the value, there's a value that is incorrect.
Yeah, use point 0.6 or 0.59 so to get 31 and 33.
Point 0.6,
Well,
no.
in place of one of the ones in the equation.
Mm. The wind velocity. Just the wind velocity, wind velocity, wind velocity. Um, all right, let me just try another figure. Let me just see something here if it is. Well, it could be the possible. Yeah, I see what you're saying. Um, the velocity mean pressure. If you put 22 to 25, let me see something. I'm not sure why that never come up. Um, 25 dot. It should actually come back to that, but it seems as if there's some mistake here.
Sir, I reduced the velocity to 130. If you
If
want back
the
the
velocity, if I move,
31%.
if I put the velocity to 130, how much you got?
31.25.
Yeah, it seems as if the velocity had a problem. Um, put in the point nine. Let me say point nine. Yeah, you're right. Yeah, you're right. The problem, the mistake is the velocity. All right, so good. That would pick
Excuse
it
me,
up.
sir. In the exam, is the velocity always given, sir?
Say that?
In the exam, is the velocity always given?
No, and that is why I start from the table. You get me?
Yes, sir.
So if it's not given, the thing about it, the principle of me checking would remain as is. So in this case, no two-person, well, let me not say, I don't expect the entire class, depends, may not necessarily have the same figure if it's not given. You get me? But what, just as I picked it up here a while ago, which this is actually 130, actually 130. Yeah, it's actually 130. Then you should know what you can actually use a figure based on what you would use. I mean, if we were using the 160, then the Q would be incorrect there. Okay, so we'll use what we get in terms of Q. But you understand in terms of applying the, let me just remove this as well. All right. So this is, all right, 130. All right, so we can continue then, right? Or you seem to have it down to a level. All right, so 25 is 34.57, and the 30 is 36 point dot. All right, all clear? This is a mean roof height that we are interested in. All right. All right, so mean of H. All right. All right, so what we need to find now is what is referred to as the internal pressure, the internal pressure. So the internal pressure, which is, so the internal pressure, so this two, all right, so, sorry, internal pressure. So in finding the internal pressure, right, we are going to look at table 26.13-1. And the building, it says that the building is enclosed, right? And because the building is enclosed, can somebody find it there? The formula in terms of what we will be using is G, right? C P I, which is equal to plus and minus 0.18. Everybody clear with that? All right. Then we move on to the external pressure, which now becomes the problematic part of this. So the external pressure, all right, we already know in terms of the length. Well, did I give you the length of the building? Did I give you the length of the structure? No. Let me just give you some general information here. All right. So the length of the building, the length of this building is um, 85 feet. And we know that the width is 40. All right. If in this case, if I ask to say that the wind is moving from west, from west to east in the eastern direction, it means that the wind is moving from eastern direction, is moving from there, from west to east. Northern direction is moving from south. All right, so let's move on. All right, so external pressure. So the external pressure, we need to understand that the length, we know what is the length in terms of, do you recall what is the length? You know, so the length is the longitudinal parallel to the wind direction. So, so in this case, for the walls, so we're looking at walls for the external pressure, all right, walls. we see that L over B, and L in the western direction. The western, we're looking only at in this case, we're just looking at one direction for now. All right. So the western direction is 40 over 85, and that is equal to 0.450. And this is west to east, or east to west. All right. So we get this. All right. So the other thing that we need to find out is the CP. Remember the CP value, which is the coefficient, external pressure, I mean factor. We we will look at table let me see, the CP table. Um 1 minute there, table, let's find it. CP table is 26. So we're looking at using the directional method here. All right, the directional method table. All right.
Figure
So
27-3-1.
20 what?
27-3-1.
Figure.
Yeah, figure 27.3-1.
Okay. Okay. All right. Yeah, this is what I want to look at. All right. So this table gives you now a rough idea of the CP value. All right. So if you're focusing on that table, the CP value for this windward wall. So CP value is zero point 0.8, and I'll just windward. All right. Windward wall. All right. The side walls, which is a CP value for the side walls, CP value is negative zero point 0.7. All right. And this is the S wall, side wall. And the leeward, so we're going to be looking at the leeward, and that is 26 point, um, okay, sorry, not that one. So the leeward, which is CP for the leeward wall, is, and yeah, this is negative zero point 0.5. Okay, and this is from west to east. Okay, we are clear on that, right? How we get these figures? Let's go. So windward, see that? And we say leeward, which is, side wall. We got that, right? And then we have which other wall do we have? So we have side, leeward. Leeward is, what did I say the leeward is again? Okay, 0 0.5. All right, how do I come up with that? Remember, we're looking at what? L over B. What is L over B? Which is this, right? Yeah. So it says that if it falls between 0 and 1, it is. You see that? All right, good. So we got that. All right. Then we can move on. We can move on to and I'm just focusing on one direction here. All right. So we're going to be looking at, all right, let me just ensure that I don't, um, Okay. All right. So a while ago we looked at the wall. So now we are going to look at the for why is this so right now we're going to be looking at the roof. I keep using that. So we're looking at the all right. So this is for um all right. So this is all right. So for roof. All right. So for roof. So for the roof now, in terms of for the roof, the roof is all right for the roof. Let's go. And it's a little bit tricky here. It is H over L, which is 25. So this is where the 25, the mean roof height becomes important. 40, right? This is equal to 0.625. And the angle of the roof is, we already calculated this, 26.56. So we are going to be looking at, so for the roof, so this is focusing on the roof. We just look at the wall. So on the roof, we want to look at the windward section of the roof. So we're looking at the windward, um, the windward section. All right, windward roof.
Sir,
So
question.
yeah,
What if the roof was actually flat?
if
What
the
would
roof
you...
was actually flat, let me tell you what you use.
I found this on the web
Sorry,
for what
sorry.
is the
So all right, so if the roof, where is it? Oh, if the roof is actually flat, I want you to note this. It says so for normal to ridge. What do I mean by normal to ridge? So if you look at the board, if this is the structure. Oh, just give me a 1 minute here. So we get something better. If this is you're seeing my board, right?
Yes, sir.
Something like that, basically. So in this case, we say normal to ridge. All right, to ridge. And we're saying that normal to ridge, which is this, the angle here is greater than or less than. If it was less than, if we were dealing with a flat roof, then we'll use the bottom part of the table, which is this part of the table. You see me?
Okay,
You
sir.
got that? So, but because it is greater than, this becomes important if you were asked to, this bottom part of the table, because now we're looking at the wind effect coming in this direction, basically. But if we were looking at the wind direction going this way, right? Then we would depends. We would approach it here. We would use this part of the formula. All right. But in this case, we're looking at the wind effect basically going from west or east to west.
Sir, one more question. Seeing that
Yeah.
we are just going in depth with these questions and homework is due tonight,
No,
we
we're
actually...
not going in. I'm not going in depth.
No, but say the homework was due tonight. That's what I meant. But say we did it, but there are some factors that are coming to play now that we might not have considered. Would you give us an extension, please?
All right. That will be answered after.
Okay, sir.
All right. Yeah, I know the pressure is on. All right. So let's go back to this part of the question. So the wind load. So we're looking at the windward. All right. So we're saying that the windward, there are two cases in terms of dealing with the windward in terms of the table. All right. To find the CP value. All right. So look at the two cases. Let me look at this. Let's go back to this table, which is table dash 26, 26, yeah, 27.3 dash 1. Look at this. We were looking at, I want you to note the angle that you're looking at. The angle that you're looking at is this, is between that. You see that? Clear? You already calculate the factor, which is h over L. And h over L we had gotten 6.625, which falls between here and here. You get me? Zero point 0.5 and 1. So therefore, you are going to be looking at, look at me now. You're going to now look at interpolate. You're going to interpolate in order to, for case one. So for case one, you're going to interpolate between this number, right? And this number for, for angle, for this angle 25. Remember the angle that we are looking at is 26.56. So we are going to interpolate between here and here as well. How do we do that? Let's go. So in order to interpolate between that, um, yeah, I want you to help me here in terms of the interpolation. So we're going to look at, say, for case one, all right? So case one is just finding the CP value, all right? So the H, I could put it in a table form, all right? So so this value here, so this value, so we're gonna structure the table, H over L. Here is the 25 that we talk about, and this is a 30, all right? But it is going between, which is the H over L is going between zero point 0.5 and zero point 0.1. I mean 1.0. And we got the figures to be minus zero point 0.3, right? And minus zero point 0.5. All right? We got this figure to be um for 30 to be minus point. You're following in the text, zero point 0.2 minus zero point 0.3. When you interpolate between this and this, you are going to come up with a figure. You are going to come up with this minus 3.35. And why am I writing this so small? 2, I mean 0.225, right? And this is for what we are looking for, 0.625. Do you understand this? In terms of, you can easily interpolate, right?
So you can go through that, sir.
All
Thanks.
right. Just to use a typical example, I don't sure how you approach your interpolation, all right? But I'm just going to just draw something like a triangle. And I'm going to say that this is 1. Sorry. This is what? I'm going to say this is zero point 0.5. And I'm going to say this is zero point 0.1. And I'm going to say this here. It could be in the negative, but the value, I already know that is, negative and negative. That's what you interpolate, or negative and a 0. Here is zero point 0.3, here is zero point 0.5. All right. So 0.5 correspond with what? Point 0.5 correspond with point 0.3 and 1 correspond with here. So if I draw a line there, the figure that I'm looking for is what? It falls between here, which is what I'm looking for is 0.625, right? So we know it's going to fall between there. So you interpolate, so you know, say between that, this is zero point 0.5 is equal to, this is what? 5 and that is what? 5 minus, that's what? Zero point 0.2, am I right? Am I right? Yeah, not talking to me. Talk. So here is 0.125. This is supposed to be x. You know, you cross multiply. Um, basically, so this becomes, I'm not sure, hopefully right, or you may have a easier way that you work it out. And you're supposed to get a figure. That figure is added back to whatever you get is added back to zero point 0.3 plus whatever you get, which is x. It's supposed to get whatever this figure is, which is this. Okay? Which is zero point 0.3, negative 0.35. Okay? All right, we clear with that?
Somewhat, sir.
Ah, no, this is important. This part is important. What is about the formula? You see, you understand the interpolation formula?
Sir, you create a formula, sir.
Sir, good question.
Do you have an interpolation formula that you use? This is my way of interpolating. So I am interpolating between point 0.5, zero point 0.5 and 1. So zero point 0.5 and 1, which is here. So when I minus zero point 0.5, I get this. I mean also minus zero point 0.3 from zero point 0.5 and I got zero point 0.2. So I'm saying that that is equal to like basically a triangle. And then I'm saying the here, which is this is here is zero point 0.5 minus zero point 0.5 from 0.625. I got 0.125. I don't know the value, which is x here. I don't know it. So that is equal to x. I'm trying to solve for x. When I'm solving for x, cross multiply, divided by 5. I'm going to get a value. I'm not sure what the value you get. You can give me there. But when you get x, it's going to give you the figure, some form of figure. It's going to give you um, it's going to give you a value that this correspond to. What is the value that is, what is x? What is, when you work out x, what do you get as x? Anybody work that out? When I worked it out, I remember, I'm not sure it. I don't have it here. You got that? Nobody worked it? Nobody understand? Oh, man.
Well, sir, from what you put up is 0.05.
What I got? What is the answer for x?
0.05.
0.05. That's what you got, right?
Yes, sir.
So I'm saying that you add it back to x. You add it back to where you're coming from, which is zero point 0.3. So zero point 0.3. So zero point 0.3. So let's go 0.3 plus 0.05 is equal to 0.35. You got that? No? Tell me that you don't lost, please. Or if you lost, please tell me. How do you normally do interpolation? Do you approach it this way? Mhm. However you do it, you should get back the answer. But I'm giving you the concept behind it. If you understand the concept, some person seems to out of it.
Sorry, like I know how to do it, but when I look at it, I realize that you're doing two sets of interpolation, if that makes sense. It's two
Well, in
sets
this,
that I have to do.
yeah, I'm doing two sets of interpolation for this
Okay,
particular.
sorry.
So I just did one for the for just the CP values. So I'm saying that
Okay.
when you do that, you're going to get another value. So I just give you an example of how you would approach in terms of interpolation. Um, that's how I would approach it. But you say you have the calculator, so back in my days, I had to manually. Oh, no, 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 what? Oh, no, no, use a calculator. Oh, online. Yeah, but do you understand the concept that I have outlined here? So just know.
Yes, sir. I do.
Okay, all right. Because we know that the value is going to fall between zero point 0.3 and zero point 0.5. If you get something over the outer that or below that, then it can't be. Okay. All right. So what you're going to find is that there's going to be a series of interpolation in order to find these values. So just now we interpolated between just to find the CP value. All right. So to find so let's go. All right, let me just go back to. All right, so let us go to now. So this is CP value for CP1. But we're going to now find because we have theta, and theta falls between 25 and 30. But we had gotten minus 0.35 and minus, I think it's supposed to be minus 2, but I'm going to put it here now. All right, so now we're going to find theta. So again, put it another formula, a table, which, a bit easier to understand. So we want to find theta. And theta for 25, which we have up here, which will come in from here, is theta 25. We know that this is minus 0.35, and we know that. Do you understand why we're trying to interpolate between 25 and 30? Because we're trying to find the 26, the angle, you get me? Of the roof, which is 26.56. All right, so theta, this, all right? So therefore, the interpolation, when you interpolate between 25 and 30 and to find the 26.56, when you interpolate between that, again, you're going to get minus 0.311. You get that? So if we interpolate again, you understand the interpolation, so I don't need to go through that. So that's case one. All right, so this is case one. Case two, let's go back to, so this was case one based on, let me just erase this. So case one was based on this value, yeah? Because remember the value that we had gotten falls between, which is the ratio of H over L, falls between zero point 0.5 and 1. So case one was that. Case two, um, so case two now, which is which now falls between, which is case two is this figure, right? And zero, this and this. Okay? All right, so that's case two. Case two. All right. So let's go. Let's go back to this. So we're going to go case two now. case two. So in case two, we are saying same thing, same formula, same table that we put up above, which is H over L, right? And H over L is 0.5, 0.1.0. What we are looking for is what we are looking for. Oh, let me just work that out. Did I work that out? Did I work that out? Okay, sorry, yeah. We worked that out already. So this is 0.625. All right. So the numbers that we are looking at, which is 25, and we just established there 25, 30, 25 is zero point 0.2, 30 is 2, this is 0, and this is zero point 0.2. So you understand it from the table.
Sir, sorry to cut you, sir. But how you get the 0.625?
0.625 is
Yeah.
the is H over L. What is H?
Oh, never mind. I got to know, sir.
You got it now?
Yeah,
Okay,
yeah.
which is yeah. And remember the L, just before you ask the question, the L is the is parallel to the direction in which you're asked to analyze. You get me? That is important. All right. Yes, Javarsi. Who was asking the question? The table above the which one? Okay. Case one. Mm-hmm. All right, what you got these two? What were these values? All right, good. So let's go back to the table, which is this and this and this. You see that? Uh-huh. Which is this. All right, so this 25 is the corresponding 25, which is minus 30 minus, yeah, because that is the reason why you find this, is because the angle is between 25 and 30, but you can't just move to it just so. You got to interpolate because you get a figure also that is between um the ratio of H over L. So you have to interpolate twice. So you have to interpolate that and then interpolate that. All right. So we're good the way that is concerned. So now that you have gotten that, right? So let's go. This now becomes this now becomes for case two, uh this become 0.15, and this becomes basically automatically zero point 0.2. All right. So this is case one, um, finding the CP value. So we're trying to find this. This is a CP value for that. So these are the values. And now we're going to find the theta values. So the theta value here, all right. So so theta, so we're looking at theta here. All right. So now we come back from to 25, and 25 we got to be 1 5, and then we got 30, and then we got this to be zero point 0.2. So the value here in terms of the 26, the angle that we're looking at, 50, that is 0.166. All right. So that is the value. All right. So now that we have established that, all right, we can now move ahead because we now have our CP value. Why do we need our CP value? We need our CP value to calculate the design wind pressure on the structure. And we know that the design wind pressure based on based on this table, which is this is what we're really trying to achieve basically here, where the H is a mean. So we're trying to find the external factor, which is CP for the roof, for the wall, and so on externally. So that's what we are going to know, is to now calculate the CP, which is the design, the wind speed, the design wind pressure. So the design wind pressure, I think this is supposed to be three. This is supposed to be three, I believe. So the design, so therefore this is the design um, wind pressure. All right. So the design wind pressure, which is P Q. I need to just check something. I hope this was what I had as a formula. Minus, all right, QI. We'll call it I for now. Um, and this is G internal factor. And we know that this is internal, this is external. And this is where it becomes a little bit interesting. Interesting.
Sir, quick
Yeah.
question, sir. For the internal pressure, it's supposed to be when you go up, sir. Go up
Wait,
to internal pressure part. Just clarification.
yeah, what about the internal pressure?
So it's that value is actually 2 point plus two or plus or minus 0.1 here, right? Just clarification.
Wait, which one? Which one? That? Which one is? Which
That's supposed to be up two, up more, sir, up more.
this?
Internal pressure. Internal pressure.
The internal, external. Which one? This figure here? This
No, sir.
table?
No, sir. Not that table, sir. Not the table, sir.
Oh, okay. The internal pressure. Where is it? Oh, you want me to go up here?
Yeah,
So the
just
intern. So
clarification,
the
sir.
internal pressure is here.
All right, sir. Thank you.
So the internal pressure. That's a table that is given.
All right, sir. Thanks.
Yeah. All right. Which the classification, the enclosed classification. All right. To get the to get the internal pressure. So the internal pressure I think is 26, chapter 26. Let me see. Internal CP value. See it here. So it's 26.13-1, which is this. Because I'm saying enclosed. You get me?
Yes, sir.
Yeah. Yeah. So that is what you look at basically. Yeah. Because yeah. The
So
thing
this
about with
table
that
will be
the
given
thing about
in
with that sign, go on again.
this table will be given in the exam, right, sir?
Yes, man. These I don't expect you to know these at all. Your head. Because the whole concept is for you to able to manipulate the table. Because that is the knowledge that we're trying to test, basically. Use the table and apply it. All right. The only thing with the assignment, I mean, you which I know somebody submitted, I'm not sure who else submitted, but I didn't say to you to if it is enclosed or you you could have gotten a little bit more detail, but I never expect that, to be frank with you, where you start to look at all your openings in the wall that you're looking at and make a calculation to say if it is partially enclosed, open, or so on. I didn't get to that detail, but you can get to that detail. Okay, so I will continue. All right, so continue on this, which is this formula here. All right. What are we looking for? We're looking at the windward walls, and then we're going to look to the roof, side walls, and then look to the roof. So let us look at the windward, the windward. All right. So you can help me here. So we already established some factors already, where G is equal to 0.85. We already know that CP, right, is zero point 0.8. Did we establish that CP? Remember? Um, where is it? For the wall, remember that? I'm not sure if you recall that. Where is it? Have I over? See it here. You see this? This is what we're looking at. So this is the external. See that? Remember that? Also, this is supposed to be. So this is supposed to be 4. Yeah, yeah. Um, so this supposed to be 4. Okay. All right, this is supposed to be 4. All right, this is supposed to be 4. Let me just put it here. All right. All right, that's 4. All right. Okay. It doesn't pan. All right, so let's continue. All right. So now that we have established some stuff here, we are establishing some parameters, using out the parameters. So we have CP, and we already established that our G, all right, CPI, which is internal, is equal to plus or minus 0.18. All right. The Z, which is QZ, right? That's what we require in terms of the height. Um, so we can safely state that QZ varies, QZ varies, but H is 25 because of the mean height, 25 feet. Remember that. All right. All right. So we could say that. All right. So we're going to we're going to use up a table here, and we're going to input our information with regards to the Z. All right. Remember, we have been working with a Z, which is from the windward side. So let's go. So, so in working with that, all right, so first we have here Z, and we have 15, right? 20 counting in sets of 5 based on the table, all right? 30, all right? And we already established that Q of H is equal to, all right, I'll get to that, all right? So let's go. So we have KZ. We already know the KZ value. You know we get with this KZ value, right? From the table. 85.9, 0.94, 0.9 that. All right. So we have already gotten this based on the workout that we had some challenges there. This is equal to 33. All right. So this value was Q. Z, all right, QZ. We want to find the, I think, what do I have here? So we want to find the external and internal pressure, all right? So the external pressure, all right? So we could say the, take off this, take out this top line here. All right. All right, so here we have the, what they call the external, all right? So we have the external, all right, pressure, all right? And the external pressure here, and we have the, which is the external pressure is denoted by this, which is this, we could say, we could call this QGPH. And this here is the internal, all right, pressure, all right? And we could call this what? QI GCPI, all right? Here we have the net, the basically the net pressure. Let's see something here. Yeah, the net pressure um, is in this, the net pressure, all right? So it is here, we call it, I could just call it um, P positive, and I call this P negative as the net pressure. So let's go. So and this is the windward wall. All right, this is the windward. So the windward wall here for the external pressure, if you should plug this, right? I mean, from the equation, plug in all of these numbers here that we have here, and then we have gotten, we would get something like 21.26. All right. So that is from this. That is from this. All right. So that is why we got that. So that's 21.26. Are you following me? Are you sleeping with, are you sleeping? And in Javarsi and the others? All right. Because you
Sir,
say you're
I don't
sleeping.
understand where you get the 21.
All right. Let me get the 21. So let's go. So what is the Q value that we are, where Q, the Q which is QZ, 31 multiplied by, so this is supposed to be 31, right? Multiply 31.58 multiplied by 8, 5 multiplied by 8, 5, right? Multiplied by zero point 0.8. What you got when you multiply that? You see these values that I put in? This value, this value, this value, this value. You should get this. But
But
remember,
sir, why did you multiply again by KZ? Haven't we already done that in order to get QZ?
okay, yes, you're right. So take out that. Take that out. Yes, that's what we did earlier, right? Yeah, yeah. Thanks for that correction. Yeah, because we got this when we multiply. Yeah. All right, so remove, yeah, remove that for true. Go on. Yeah. Yeah, yeah. I forgot that we established because sometimes what you can do, you can actually bring you could actually have your Q value with your KZ. Yeah. All right. Keep it as is. Yeah. So thanks for that correction. So basically, that is what you apply, how you apply that formula there. And that continues. And this continues in terms of this becomes 22.51, 23.51. We're saying 24.51. Internal is taking this part of the equation, right? All right, so that becomes this internal becomes what? 6.22. And this, remember, this internal, yeah, yeah. Am I correct? Yeah. So this becomes 6.2, um, 6.2, 6.2. So
Sir,
the,
how we get the 6.22?
oh, what I didn't establish, let me put this here. Let me put what this K, this Q, this QH is equal to. All right. So if you should multiply, let me check something here. So tell you. All right. So just go ahead and multiply for me for the value. This this value, right? Multiply multiply
By the
by
0.18.
the no is well 0 point which one?
0.18 at the top, sir. Well,
Yeah, 0,
that's what I did.
0.18 multiply by what?
34.568.
Yeah. This 34, where did we get this again? We established it from here, and I wanted to make that important note. The age that you use and the corresponding value is the value that corresponds to the mean height. The mean height was 25, and that is why I put it here. You get me?
Yes, sir. Follow.
Mm-hmm. So, yeah. All right, so we're clear. So now that you have established that, yes? Yeah, it corresponds to a Q value, which becomes this. So this is the value that you're going to be using with the 0.18. And so you find out, yes, yes, yes. All right. So now that you have established you're going to be doing a positive net pressure, what is the positive net pressure? So the positive net pressure here is is 15. Sorry, let me just use another color. All right, so the positive, which is this, which is 15, right? 0.03. This becomes 16.28. This becomes 17 point that. This becomes 18.28. How you get this? If you should remember, we are looking at the positive. So if you plus this, um, mhm, how should I best explain this now?
So, sir, the positive is when
The
the
positive,
positive is when
positive. So say that again.
the positive is when
when the GCPI is negative, right?
Yeah. So you're basically taking, you'll be actually put it in here. See the formula here. See the formula here. All right. 1 minute. Give me a minute there, please. All right. Sorry about that. All right. So let's get back to this. Yeah. All right. So this now, so this value becomes the negative value. All right. Okay. All right. So this now becomes, external pressure. Okay. Sorry. Sorry, it's giving me a problem. All right. So this now becomes 27.84. All right. This now becomes 28.73. This becomes 29.7 3, and this becomes 30.7. All right. So this is the wall for the windward. So if we're looking now at the other aspect of the wall and the roof, right? So this was the wall. Did I put it there? This was for the windward. All right, windward um walls. All right. So now we're going to be looking at the um the side walls and the roof and the leeward and the leeward the roof, yeah, leeward. No, no, it's plus and minus. Yeah. Say that. No, oh, sorry. P is but oh, sorry. So it is the net pressure positive and net pressure negative, because there's going to be a positive pushing and there's going to be a pulling. Say that. External and add this and this, yeah. Because if it is negative, a negative, because remember the formula, a negative, it's all of these value we take on a negative. So you're saying that this value take on a negative basically. This value take on a positive basically. You get me? So this value coming in the positive, right, takes on a positive here. If it takes on a positive here, then because of the sign, it becomes minus. This value, the negative net pressure, takes on a negative. A negative plus a negative and a negative gives you a positive. You get that? So that's why you get that. Clear?
Sir, could you go over again how you get the 6.22, sir?
So the 6.22 is this 34 multiplied by this. Remember the formula. This is a formula. So this is what this is the external, this is the internal pressure, and this is the external. So that's why we break it up like this. So internal, external. So if you multiply one point one eight, then you get this. But you realize it hasn't taken on the negative values until we calculate the net pressure. You get me?
Yes, sir.
All right, good. All right, so we can move on now and kind of wrap and kind of close off this to some extent. Um, let me see. All right, all right. So let's bring it home. All right. The so the all right. So we can go back here. So the so we want to find for so we were looking at the windward. So now let us look at the side walls. All right. So the side walls. So let's go. So for the side wall is this, which is a CP value. Remember CP value sidewall, that is what we're interested in now because it's on the external. So again, you can actually put it in for ease of calculation, find that easy. Um, you can actually put in a table and we are saying this is external P, all right, external pressure P and let me see, internal pressure P. All right. So let me see something here. The CP value that we have here was, let's go back, zero point 0.7 for side. So let's go back, let's go to that. So the CP value for the side wall, where is it? Which is this. So we said CP value for side wall is negative zero point 0.7. What is this? Um, something move? Oh, this is supposed to shift. No. Oh man. Something shifted there. Why not going back? Oh man. Okay. All right. Yeah. All right. So we got that. So you understand that. So that's what we come on, man. So that's what we're working out here. So if you should put in these values in terms of the CP value. So again, let's go. So if you put in the CP value, which we got, which is the CP value for the sidewall, which is minus, yeah, 7, then this figure becomes minus 20.57. This figure, internal pressure, internal pressure becomes like what we got, that. Again, we're doing the same CP plus and I mean, the net pressure. So the net pressure we want to find, which is net pressure P positive is equal to minus 26, right? Minus 26 point, sorry, that is not right. Yeah, 26, yeah, 7.9. And this is P equal to minus 14, 35.535. You get that? So that is for the wall. So if we're now going to look at the leeward wall, so we're looking at the leeward wall, right? So the leeward wall is, and in this case, we're looking at the leeward wall and we're looking, see, we're only focusing on one direction, east to west. All right. So the leeward wall, we have the CP value that we have is equal to minus 0.5. Okay? And the external pressure, let me just correct that. So the external pressure, if you put that in the formula, you get minus 14.69 internal pressure is again 625. Then we have the pressure positive is minus 20.91, and pressure negative we have minus 8 minus 847. All right, so that is it for the leeward. All right, so let us go to the roof now, and then close off this for the roof. So let's go. So we did for the wall. So we're now going to do for the, all right, you're following that, right? So let's go to the wall, to the roof. So we are looking now, which is, I think this was 4. So this is 5. So we are now looking at the same east to west for the windward. So we're looking at the windward roof. So for windward roof. All right. So for the windward roof, again, remember the CP value, CP1 is equal. Let's go back to it. We got that. Let us CP um, CP1 is equal to this. All right. For the roof, which is case 1, we get that. All right. And then for case 2, we're going to be using this. All right. So this is for the roof. So again, for 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 case, so this is for the windward for case 1, right? And we established that the CP value here was minus 0.311, right? So the external, so we're going to put it in a table form again. So the external value, X, PT, all right? The external, let me call it EXTP, pressure, external pressure, using the equation, which is this equation, and plug it in there, which is P, and we know what this is already, QH, GCP. So this is what we're talking about, minus, all right, H, all right, and the H here, we know what it is in terms of the windward, GCPI. All right, so that's a formula. That for the external pressure, it is minus 9.14. All right, internal pressure, it is 6.2, right? The net pressure positive is minus 1.536. The positive pressure is minus 2.9. That. And that is for case 1. For case 2, right? For case 2, what you're going to find is for case 2, right? So let me just put on case 2 here. So case 2, which we already, I showed you what we got, right? So case 2, so case 2 is, again, the external pressure, right? And the CP value, the CP value, which is CP2, is equal to 0.16, right? And that is equal to 0.4888. The internal pressure is equal to 6.22. The net pressure is equal to minus 1.34. The, the positive is equal to 11.11. All right. So that is it in terms of the, so that's a roof. That's the roof. That's the, yeah. All right. So that's the roof. The thing is that there's a, so we calculated this pressure is for the windward. But what we didn't do is that the leeward part of the roof, which is the other side over here, so in terms of the direction of the roof, is to close this off, is this. So you're gonna find that the leeward side, so we did the windward, so for the leeward is roof, right? Same formula, which is P, Q, H, G, right? So the CP value for that, for the leeward, is 0.06, 0.06. Let's go, 0.06. So the external pressure P, right, is equal to minus 1763. The internal P is equal to 6.2. The positive net pressure is minus 23.85. That is equal to 11.1 dot dot. So this is the basically how you would approach it in terms of the wind effect. All right. Are there any questions?
Sir, go back to that the last table, sir.
The last table. So we would have gotten that out from when we did the roof. The roof. Let me see. The roof. Where is it? Where is it? Where is it? For roof, where?
Shouldn't it be 0.625?
Say that again.
Shouldn't it be 0.625?
62. Where you see that? 625. Where you see that? Let me see.
At the top where we have the red, at the starting of the red writing, sir. It's
You
over
mean
there.
here?
Yes, sir.
Let me just double check something. I don't think that's where it is. Oh, sorry. There's something. Oh, I didn't put it in. I didn't put it in. Um, Let me just go back to the formula. Let us go back to this quickly. I think I left it out. Thought I did. You see where I put in these cases, right? What I should have said to you is that for the for the leeward here, what I should have stated is that the leeward for leeward roof, right? I should have stated that because the roof, the angle is greater than 20, which I'm going to go to that formula, the CP value is equal to zero point 0.6. Let me show you where that is in the table. Um, if you recall, where is this? Okay, where I find the external pressure. All right, this is it. This part, yeah, I didn't put it in right here because all the values you never need to interpolate. You get it? You got it now, right?
Okay. Yes, sir.
Yeah. So I never remember to put that in. All right, good that you point that out. I thought it was. All right, so that how you would actually deal with the pressure on the, moving from one direction. And trust me, in an exam situation, it would be hard to give you two sides. Um, all right, so we
So
understand that.
for in an exam situation, is it going to be this complex in regard to two interpolation?
It can be as complex
Okay.
as this. So I would say know this. All right. All right. Let me go through. I think moment distribution, because I think moment distribution is a quick 25 marks. I don't know if everybody's clear with it, or I just need to just touch certain areas.
Yes, sir. It and two-way slab.
And two-way slab. All right. So so let me just in there. All right, that and the two-way slab. All right, let me just go through that.